So next, what we will cover is that the first stage of the rendering pipeline, which is the application stage. What is the role of the application stage and what happened inside this stage? Here are what happened. It is done entirely in software by the CPU. It means that this stage is executed by the software on the main processor inside this CPU. So it's done inside the software. And what is the role of this application stage? The role is that it will read the input device. For example, is through glove or mouse. Okay, glove and mouse is one of the example of the input devices. So inside this application stage, it will read all the data from the input device. Okay, for example, if you click a mouse 2 times, for example, that clicking mouse will be read in this application stage. Beside that, it also can change the coordinate of the virtual camera. The changes of this virtual camera are made to the virtual camera as is required to get the coordinate of this virtual camera. Beside that, this application stage also is perform the collision detection and also collision response for the haptics. What is collision detection and collision response is I will explain later. And one of the example of this collision response is the force feedback. I hope you still remember what is force feedback in previous chapter, output devices. So what is collision detection? Okay, based on the definition here, collision detection is typically refer to the computational problem of detecting the intersection of two or more objects. So the keyword of this collision detection is detecting. Okay, based on the name itself, detection is used to detect when there is a two or more object is collide to each other or hit each other or crash to each other. Okay, so the role of this collision detection, it will detect whether there are two objects is hit each other or crash to each other or not. Okay, so this is collision detection. And what is the collision response? Collision response is will deal with the model and algorithm for simulating the changes in the motion of two solid bodies. So the role of this collision response is that it will deal with the simulating what happened when a collision is detected. Okay, so when this one is detect, there are two objects is hit each other. So the role of this collision response is that it will respond or it will deal with the it will simulate what happened next when there are two objects is hit each other. So this one will simulate what kind of simulating that it will use. Okay, what happened next after that. Okay, so this is the collision response. This one is detect first, and then this one will respond based on the related simulation. Application stage optimizations. What we can do to help the application stage to achieve optimizations. Optimization means that a process or making this stage as fully effective as possible. So how we can help this application stage to achieve this optimization? First, what we can do is that by reducing the model complexity. Model with less polygon will less to fit down the pipe. We should help this graphic pipeline so that it runs smoothly, so trying not to clog the pipe with too much data. If you look at these two figures here, I have two figures, one's on the left and also one on the right, that representing the 3D object. You can clearly see the differences here. If I ask about which one is more realistic, definitely you guys would say that this one is look more realistic because it's use more polygon while the figure on the left use less polygon. If you look at this, the number of polygons here for these low resolution models, it only use around 600 of polygons only. Okay, while these higher resolution models use around 134,754 polygons. That's why it look more realistic. But in order to optimize this application stage, it is better, or it suggested, to use less polygons, so that is require less data, so that is not gonna burden this application stage that much. Besides reducing the model complexity, what else that we can do to help this application stage to achieve its optimization stage? We can reduce the floating point precision from the single precision instead of using double precision. So it is suggested to use single precision instead of the double precision. Single precision and this double precision here means that, for instance, basically this single precision is the floating point arithmetic with dealing with the 32-bit floating point numbers. Okay, single precision is for 32-bit floating point, but double precision here means that dealing with the 64-bit. Okay, this one is 32, this one is 64. And then since this application stage is done in the software inside the CPU, so it is suggested that to use the dual processor, or we can call that as a super scala architecture, to support this stage. Okay, so it's recommended to use this a dual processor or super scala architecture to support this application stage.